Continuing with the theme of the previous lesson, we're working through just specific cases of trigonometric u substitutions that we can do. So the setup this time is if we have an integral that involves an even power of sine or cosine. So if the problem is largely sine and cosine, and if you've got all even powers, or if you've got a single even power, the strategy that we use are called the power reduction identities, and you do that to remove the powers of sine or cosine, and then you can just integrate using substitution. So specifically what I'm looking at here is the identities. If you have sine squared x, the thing that's the same as that is 1 minus the cosine of 2x over 2. Similarly, but a little bit differently, cosine squared x is 1 plus cosine 2x over 2. This thing I might mention about these, what if the problem was like sine squared of 5x, right? We recognize that it should fit this pattern, right? It should be something like 1 minus the cosine of something over 2. The question is, what's the something going to be, right? Well, this up here says it's supposed to be 2x. It's supposed to be 2 times whatever the original argument was. So if the original argument was 5x, it would be 10x here. Right? Something we'll see in a later problem. One other way these problems can get a little bit crazier is what if you have something like cosine to the 4th of x? Right? Can this method be used? And the answer is sort of. What we have to do is we have to think of cosine to the 4th as cosine squared x squared. We'll have to look at that as 1 plus cosine 2x over 2 squared. And then when we FOIL that thing together and we get, 1 plus 2 cosine 2x plus cosine squared 2x over 2, over 4, we're sort of going to look at this thing and effectively have to use this power reduction again on the squared piece that's left. So it's a little bit more involved, but we'll get to that when we get to the practice problems. So here's the first one, really simple, hopefully really straightforward. This is the integral of sine squared x, a problem that previously would have just been impossible for us. Can't really do it. Now we recognize, hey, this is just the integral of 1 minus cosine of 2x over 2. If I pull that 2 out front, I'll end up with this, which I hope we all can admit is a really easy integral. Like, this should be something that's very simple to us. Technically, this requires u substitution, but because the thing inside has a constant derivative, should be very simple for us. So if you haven't already done so, pause the video, work out that integral on your own, just to sort of make sure you're keeping your basic integral skills, up to snuff. So this is going to be 2 times x. Integral of cosine is going to be sine, so we're going to get negative 1/2 the sine of 2x plus c. The final step is just to push that 2 back in. So 2x minus the sine of 2x plus c. Really nice and straightforward for a problem that used to be impossible to us. So the next problem, I'm asking you to find the general solution to this differential equation. And this may feel like, dude, that's not fair, like we haven't even talked about differential equations. What I hope you guys remember about differential equations is that at this point in the game, all we know about are separable differential equations. What we always do is we multiply this over, so we get dy equals cosine squared 5t dt. Now, since the variables are separated, I can just integrate. I'll get y equals, and now all you have to do is do this integral. So pause the video for a minute or two, work through that integral, and then check the answer. So we will do this problem by transforming into 1 plus cosine of 10t over 2 dt. Right, I'm going to take this constant of 2 and pull it out. This gives me y equals 1/2 the integral of 1 plus cosine of 10t dt. Y equals 1/2 t, and then this again is a cosine. These end up all being cosine, so this will be plus 1/10 the sine of 10t plus c. And then the final step in my mind is just pushing in that 1/2. y equals t over 2 plus 1/20th the sine of 10t. Okay, so when it's just sine squared, when it's just cosine squared, they're really not terribly complicated. They tend to be fairly straightforward, just like this. This problem here is sort of in my opinion, the hardest that we may even possibly have to deal with. To be honest, the AP and IB exams generally stop at sine squared or cosine squared. Sine to the fourth is a little bit more possible, cosine to the fourth a little bit more possible, but it's a pretty involved problem. This problem is probably going to take a little while, so make sure you have some mental fortitude, and then get ready. What we do, right? What we do, as I sort of mentioned in that first slide, is we think about this thing as being sine squared x times sine squared x, right? And then each one of those things is going to get power reduced, right? So I'm going to get 1 minus cosine 2x over 2 times 1 minus cosine 2x over 2. Right? So I want to pull the 1/4 out front, just because I don't want it to be in the way anymore. So 1/4, the integral from 0 to pi. Then these two things here get FOILed together. Right? You'll get 1 minus 2 cosine 2x plus cosine squared 2x. And my thought here, again, and maybe I should ask you guys to pause and sort of think about this, right? Pause and think about how you're going to do this integral, how you're going to process this thing. I hope you recognized the 1 is easy. That's just going to be x. This one's going to be pretty easy because it's just a u substitution. This is the only one that's really going to take us any work because it's squared. I'm going to have to go through my power reduction stuff for that. So what we can actually do, remember we can split integrals, right? We can sort of do this as, this part, this 1/4, the integral from 0 to pi of 1 minus 2 cosine 2x. That can be done without much trouble. This other one, this is going to take more work. And I should have done that in a different color. We'll do this one in red as we go further along. Let's deal with the left blue integral first, and then we'll deal with the other one once we get past it. Right? So this blue integral, I have 1/4 x minus 1/2 sine 2x evaluated from 0 to pi. I just realized that half isn't supposed to be there, right? Because you've got the 2 that's there, and then times the 1/2, we're just going to have a sine 2x. Yeah, that's right. So now when we go back and plug in our values, I'll get 1/4 pi minus 0 minus 1/4 0 minus 0. So that's actually particularly nice. This entire blue side over here just becomes pi over 4. So all of this is just pi over 4. We have all the rest of this space to sort of work out the other thing, right? So I've got 1/4, the integral from 0 to pi. Now this one, it's cosine squared, so I'm going to get 1 plus cosine of what? Think about what needs to go inside there. Should be 4x all over 2. Right? Then just like we did before, I'm going to sort of pull the 2 out front. This will give me 1/8, the integral from 0 to pi of 1 plus cosine 4x dx. And now this integral is sort of the same level of difficulty as this one that we had up here. There's just a little bit more stuff going on around it, right? So I've got 1/8 times x plus 1/4 the sine of 4x, and this is evaluated from 0 to pi. Actually getting close to done with this. So we've got still our pi over 4 plus 1/8 of pi plus 0 minus 1/8 times 0 plus 0. That actually worked out really nicely because those signs all ended up turning into 0 for us. So I end up with pi over 4 plus pi over 8. And my final answer, let's see here, blue plus red is purple. So I end up with 3 pi over 8, when I combine those two things. Okay, a pretty involved problem, but again, I hope that we have some of this appreciation for there are more and more and more integrals that we're able to do. There are fewer things that we need to be scared of. I suppose it's frightening because it means there's more and more stuff that can be thrown at you. But integration is a challenge. Integration is the way that we should feel about math, the way that we should be approaching challenges. So I hope that you guys are embracing these new strategies and just getting ready to use them.